Can everybody hear me? Okay. We'll start quickly and we'll wrap up very quickly also, right? It's almost 2 and I think everybody might be hungry. If I'm looking at the phone in between, I'm looking at my talking points, I'm not scrolling Twitter. We'll start. My name is Yash Kalvani. I work at FlexiLoans as a principal engineer. Yeah. Our today's topic will be scaling geospatial data pipelines, right? If you really think about it, the entire point of having geospatial in a bracket is because data pipelines are eventually, it's just data, right? Now, whether it's geospatial data or whether it's normal data, whether it's maps, whether it's continuous data, whether it's any different type of data, it doesn't really matter, right? You can apply any and all of these principles to scaling your pipeline, data pipeline, right? So I work as a principal engineer. I'm mostly active on Twitter. If I wasn't a developer, I would have definitely been a barista in some coffee shop, right? And I have an open source package on NPM. It has about 30,000 downloads. If anybody is interested, you can contribute to it. It's in React Native, which I think is something that the previous speaker was also talking about. React Native didn't have some functionality, and I thought I could build it, and I built it, and I published it, and a lot of people are now using it. So I organized something called as Dev Dinners. Has anybody heard about it, Dev Dinners? Yes, one person. So Dev Dinners is basically a group of people. We come together on a single day and we sit and we chill and we eat and talk. And we don't talk about tech. I think, how many people over here are working? What's the crowd distribution? Okay, okay. So during the day, I think most of the people, just like we are here on a Saturday and we're talking about tech, right? During the day, you're talking about tech. During the day, the entire week, you're talking about tech. During the entire week, you're doing production deployments, failures, rolling back, learning something new. A new technology has come in, AI is taking your job. And on Saturday morning, you wake up and you're like, आज क्या करें? आज फिर से tech के बारे में बात करने चलते हैं, right? So when we meet during these dev dinners, we sit, we chill, we talk. A fancy thing that has now started is that people come to these dev dinners and they talk about how they're breaking production. There are people who have deleted databases, there are people who have sent out emails, there are people who have leaked their API keys, and it's just so fancy to listen to all of these things. One person just randomly showed up to the dev dinner and he's like, मैं college में हूँ, and I was like, so why are you here? Like, why did you travel an hour to the other grandmama's cafe to just meet us, people who don't even know? And he's like, मुझे पता करना था कि लोगों को job मिल रहा है कि नहीं मिल रहा है, right? He's like, you all have 5 years of experience, 6 years of experience. I just wanted to ask, आप लोगों के पास job है कि नहीं, कि AI ने ले लिया है तुम्हारा job, right? So that's what we do at dev dinners. And then I run a community with a friend of mine, which is called Mumbai, which is the Mumbai's Python user group, right? So how many of you live in Vasai Virar? Oh shit, that's like basically everybody, right? So I think this has now flipped. I don't live in Vasai Virar. I traveled for about 2 hours today to come here to give this talk. And I understand why do you want to do this in Vasai Virar, right? Because it's every time you guys coming on a Saturday morning to the other side, Chembur, Dadar, Lower Parel, and it becomes so frustrating. This was me yesterday night. I was drinking till 3. And I think we should start a petition to not have Saturday morning 10 o'clock events, right? Do it like at 2 or 3 o'clock. Like I understand even you guys, when you travel, right, it might be difficult for you as well, right? So let's have that somewhere. So enough with all of these things. We'll start with our objective for today, which is we'll quickly go through what do I do on a daily basis, why and who should care about this, what is scale, when not to scale, and scaling geospatial data pipelines, right? So I've just put down why and who should care. If this is not you, then this talk is not for you, right? If you're somebody who cares about understanding when not to scale, right? I think by default, a lot of engineers right now just default to saying microservices, queues, Kafka, AWS auto-scaling groups, and this and that and everything. And I think people don't, or people just skip the step where people should talk about when not to scale, right? From the get-go, you won't have scale. That's just how it works, right? So when not to scale, when to understanding cost related to scale, right? A lot of time, we as engineers, we enjoy building things, right? The other day, about I think 3 weeks back, somebody came to me and they said, this has now released, we could do this and we could implement it and it'll be this and it'll be that. I'm like, do you even understand the kind of cost it will cost to the company to be able to rewrite this entire thing? And we might still be just better off by 10%, right? The company is not going to invest that much amount of money into rewriting this entire application just because you found a new technology that's better than what we are using right now. So sometimes there's a lot of cost also involved that we as engineers should start looking at, right? Our third pointer is understanding what part of the system to scale and understanding how to scale that part of the system. So if these 4 pointers interest you, then this talk is for you. Otherwise, you're not in the target audience. What does scale look like? How many of you deal with architectural diagrams or microservices or architectural issues on a daily basis? Okay, shit. Total audience mismatch. So, from, let's say for example, you have this complicated architecture, right? There's a lot of things going on over here right now. People don't understand what's happening. A lot of you might not be knowing what this is. But at the end of the day, you also need to realize that at what stage is my company in right now? Is it a startup? Is it a mid-level company? Is it a growing company? Is it a large-scale company? Is it an ultra-large-scale company, right? As an engineer, you could build this and you will be a very good engineer. And when we meet and we ask the company, how many monthly active users do you have? And the answer is 5, right? If 5 people are using your mobile application, website, any tech infra that you build, then having this makes absolutely no sense, right? Because this is going to cost you a lot of money, this is going to cost you a lot of problems, this is going to cost you a lot of things. So today, we won't just simply talk about what to code, how to code, architectural patterns or any of these things. We'll also look at it from a more global and holistic point of view, right? It's about knowing how to implement, what to implement, where to implement, because आजकल तो तुम लोगों को code, architectural patterns, the entire code base, even ChatGPT can write for you, right? Is everybody using ChatGPT or a equivalent on a daily basis? Okay, perfect, right? So every day you might be doing this, you could simply just go and type event-driven architectural patterns, you could say microservices and ChatGPT will put out the entire code base. So what has happened is code has become cheap. If you're a code monkey, if you're somebody who just knows how to write a piece of code, ChatGPT has already automated you. Code has become extremely cheap. Understanding what the architectural patterns are, how to scale a service and when and where to implement this is where value lies right now. It's where you guys can tap in at this moment, because ChatGPT won't have, it's starting to get there, but it still hasn't had the entire context of your infrastructure, so it won't know whether you need this, because maybe you might just have 5 monthly active users, right? So if you're a startup who is, so yeah, this is what scale would look like in a startup, right? If you have that architecture, and this is my reaction every time somebody who comes to me and they have 5 users and they're asking microservices mein kaise implement kare, right? At a startup, if you're just starting, you have 100 users, you have 500 users, you have 1,000 users, or somewhere in the range, I think monolith is the way to go, right? There is a lot of cost associated with microservices. There's a lot of cost that is associated with microservices that happen, which we'll discuss later in the slide. But if you're just somebody who's starting out, you have a startup, you are not expecting a lot of traffic, you're probably measuring API calls in the number of API calls you get in a day instead of RPS, then you should just go for monoliths. So knowing when to scale, right? Don't do premature optimization. A premature optimization is not knowing what your eventual infrastructure is going to look like, what your eventual scale is going to look like, how many users you're going to have, which service is going to have what load. Without knowing all of those things, if you just default to saying, चलो microservice बनाते हैं, उसमें Redis लगाएंगे, system design का interview देखा था हमने YouTube पे, वहाँ पर उन्होंने ये बोला था, we'll implement this over there, we'll have a Kafka queue in between with an event-driven architecture, is just extreme premature optimization. Knowing your system is just as important as scaling your system. So again, also scale is relative, right? Can somebody just say, somebody over there, I think that guy over there, can you just put your hand up? Yeah. What is scale according to you? Just shout out, it's fine. What is scale according to you? In terms of, let's say, you have a server and you're getting a certain amount of traffic on it. What's that traffic in your mind right now? It's a large scale system. So what's the traffic right now in terms of requests per second? So what I was trying to get at is basically, it's fine, you can say. So what I was trying to get at is basically scale is relative. So for you who's working in a company, you could have 10 users requesting your API per second and somebody else could be having 1,000 users requesting your API per second, right? When somebody says we have large systems and we have big scale, what does that even mean? You have no idea about it. So having a figure that can measure what is scale is far much more important than just talking about scale randomly. So is it 1,000 users per second? Is it 1 user per second? Is it 1 million users per second? How many of you all have heard the word microservices? Does everybody use it on a day-to-day basis? Is there somebody who's still on a monolith? Monolith. Okay. So I think microservices has turned into this word where the one developer says microservices to the other developer in their ear and they get goosebumps, right? That's what that word has turned into right now. Every junior developer that comes in and they talk to me about scale, the first word that comes out of their mouth is microservices. How many of you? This is very interesting. How many of you have gone to the website called microservices.io? That website is hosted by the person who invented microservices. Everything and anything that you want to the original philosophy of what microservices is going to be is actually there. The author writes about it. There are blogs on it. And I think most of the people don't even know about the website, right? But most of the time, the entire concept of microservices and scaling has been popularized by these data science or system design interviews on YouTube or by Netflix interviews or these other interviews, right? So this again sort of goes back to the entire point that understanding where and when to implement microservices is far much more important to obtain scale at the stage where we are rather than just saying कि इसको भी microservice बनाते हैं, इसको भी microservice बनाते हैं, इसको भी microservice बनाते हैं, इसको भी microservice बनाते हैं. So this was the slide that I was talking about. So if we look over here, this says monolith versus microservices, and I was saying microservices are extremely expensive, right? Why are they expensive? Because you need to have service discovery. There are security issues. You'll have to have distributed tracing. You'll have to have distributed logging. You'll have to have distributed databases. You'll have to have roles for these distributed databases to be accessed by your counterpart application layers. So microservices are extremely expensive. At this point, if you're a startup and you're doing monolith, you're already scaling, right? So when you say innovative insights into scaling infrastructure, this is probably one of the most innovative insights that you could find is just have a monolith. Serve your 1,000 users using that monolith. Dump everything into it. Put your database into it. Put your put your servers into it. Put everything into it, and just run one really beefed up EC2 instance on your AWS, and it'll serve your entire traffic. You won't have to do anything else. Right? So now let's assume that you are a company where you have anywhere between, like, let's say, for example, 1,000 RPS to, or let's say 500 RPS. RPS is requests per second, 500 requests per second, concurrent requests per second, to about, let's say, for example, 10,000, 15,000, a million, whatever is your range, right? Requests per second. That's extremely high scale. Most of the companies that are present with, like, let's say, for example, with a revenue of 1,000 crores, like let's say for example an NBFC has a book of 1,000 crores, even they are not at this scale. Some of the ultra big companies are where you will see the scale of 10,000 requests per second, 15,000 requests per second, a million requests per second, like that. CleverTap, like for example, CleverTap is one company that has a million requests per second of scale. And Idify is a company that is right now approximately at like 1,000 to 3,000 requests per second scale. So now we are in the realm where we are saying that our monolith, one single service cannot handle that scale. We'll go to microservices, we'll distribute it, we'll containerize the entire logic, business logic into individual microservices, and then we'll navigate it from there, right? At this point is where we get into the entire actual topic, which is scaling data pipelines. Till now, what we were talking about was purely just theory, right? And now what we'll just talk about is where the actual implementation will happen. Does anybody know what geospatial pipelines, data pipelines means? Geospatial, has anybody heard the term geospatial? Okay, no. So what the previous speaker was talking about was geospatial, when the person was talking about polygons being rendered onto the map, right? When you open Google Maps, you're interacting with geospatial data. Geo means geography, spatial means you're rendering something in that geography. So it also changes with time. Like let's say for example, traffic changes with time, that traffic needs to be rendered onto the Google Maps. So it's a geospatial function, right? That is what we deal with. Which is geospatial data, for example, right? In this geospatial data, we have a lot of functions that happen. You need to change the resolution of the image, you need to reproject the image, you need to perform a certain data analytics on the image, you need to figure out whether a point, a certain latitude or longitude falls within the circle, you need to figure out whether a certain latitude and longitude falls within a polygon. Like for example, station se idhar tak ka map is also a geospatial function. Performing these functions is extremely costly and difficult and does not scale well. So initially when we started, we went the monolith route. We were like, we don't really care, right? We don't know whether our business will work. We don't know whether we will get traffic, people will be interested, people will pay for this or not, and instead should we just go and spend thousands of dollars on EC2 instances and microservices and scale and put a target group, this, that and everything. So what we initially did is we have a data source 1, data source 2, data source 3. It goes to an application load balancer which sends it to a EC2 instance. How many of you are familiar with cloud services? Okay. So does anybody know what an EC2 instance is? Most people are clear on it, or should I just go through it once? So an EC2 instance is literally just your motherboard. That's the easiest way to talk about it, right? It's just raw compute CPU power, and an application load balancer simply says ki I have 5 CPUs, out of which CPU should I send the traffic to? Over here, if you notice, we have nothing. We don't have microservices, we don't have we have literally nothing. This is as bare bone as it can get in today's time. You have data, high load data coming to an application load balancer. Application load balancer simply just sends it to an EC2 instance and we are processing it, right? If you notice that initially, this is what our CPU utilization was looking like. Initially, it was at 10, 15, 20%. And whenever our data load goes high, a lot of people start requesting us, we would have this peak, and then people would stop requesting again, and then the load would go down. And then it would again sustain at some 10, 15%, again it would go high, and then again it would come down, and then it would sustain. For the first 6 months, we did not even have this problem, right? That's where the entire premature optimization comes in. In the first 6 months, we did not even have this problem, so we never had to solve it. We could focus on other things. We could focus on hiring. We could focus on engineering. So the entire point of scaling did not even come into the picture. Most of the companies would just be like, okay, we have this service, let's just put it into a microservice, deploy it on an ECS instance, put an auto-scaling group on it, put it into Kubernetes, deploy it in EKS, and all that entire shebang, right? So for the first 6 months, we did not even have this. When we saw this in the 6th month happening, we were like, should we even solve this, right? Does this even require solving? The answer was, we eventually had to solve it, so we were like, okay, we'll take it up, right? So the way to solve this was simply, what we did is that instead of sending the data source directly to an application load balancer, we send it to a Lambda. People are familiar with Lambdas? What AWS Lambdas is? Very few. Okay, so AWS Lambda is literally just an event-driven function. Wherever that Lambda receives an event, it turns on automatically. It does the entire compute in a containerized environment and it shuts down automatically. You're only charged for that 1 second of compute instead of an EC2 instance. Over here, which is the EC2 instance, this part will always keep on running and it will always keep on charging you for that time, right? So if you're running it for the entire month, it's going to charge you for the entire 720 hours. Whereas a Lambda automatically turns on, does the compute, and then shuts off automatically, and you're not charged for it. Paisa bachega, right? So now what we did is that these Lambdas are scaled using AWS automatically. We don't scale them, we just give them a concurrency configuration and it scales automatically. So what we started noticing is that now our application load balancer was not directly receiving the traffic. The Lambda was processing a bunch of things and then it was eventually giving it to the application load balancer, which would give it to the EC2 instance. These Lambdas at a single point of time would scale to, like, let's say for example 500, 600 Lambdas are running for 5 minutes, and then at the 6th minute 0 Lambdas are running. So you only charged for that 5 minutes and nothing else. For about 8 months, we did not have any problem. At the 8th month, the company cracked a contract with the government of USA, where the government of USA would use our APIs. And what we started noticing is that once they started using our APIs, even a Lambda has a specific time that you can run it for. The Lambda started timing out. So if you notice, for about a good one year, 2 months, 1.5 years approximately, we are still not on microservices. We have just cracked a deal with the government of USA and we're still saying that, no, let's see if this infrastructure scales or not. At a certain point, we started realizing that the Lambdas were timing out. The Lambdas were running for 8 minutes, then it went to 10 minutes, then it went to 15 minutes, then it went to 20 minutes, and then eventually the Lambda timed out. At this point, we couldn't afford the Lambdas timing out. We could have afforded like about 10% of the Lambdas timing out, but it went way off that threshold. So before we move on to this, when we went on to this infrastructure, right, this was also scaling, right? So I am still scaling. And I'm still not using microservices, EKS, ECS, or any of those fancy things, right? Those are important. They were not important to us. We saved a bunch of money on not using EKS, right? Or ECS or any of these things. So we are still scaling. So this is where we went. We cracked the deal with the government of USA. We were scraping about 20 GBs of satellite data, and then we started scraping about 120 GBs of satellite data, right? So this increase is what caused the lambdas to start timing out. And then this is what we eventually did. Now, if you see, this seems very similar to the previous architecture. What we simply did is now we introduced an AWS SQS. SQS is a queuing service. Do people know about a queuing service? Somewhat. Okay, okay. So queuing service is literally a queue, right? You go to an auto stand in Thane, and then now there is a queue. Whoever enters first gets the auto first, whoever enters last gets the auto last. It's quite literally like that. What we said is, instead of directly sending the data to the Lambda, we'll insert a queue in between, which will allow us the flexibility to not even evaluate them in real time, right? The data source emits an event. That event is put into the queue. That event lives in the queue as long as I want. I want to process it after 3 years, I'll process it after 3 years. I want to process it after 3 days, I'll process it after 3 days. I want to process it in real time, I'll process it in real time. Now this gives you the flexibility of not processing something in real time. Because मुझे ज़रूरत ही नहीं है. The moment I say I don't require real-time processing, my cost goes even down. Now I can scale only 5 lambdas instead of 500, and let those 5 lambdas keep on consuming and run for 10 hours instead of running 500 lambdas and doing it in 5 minutes. I don't want it to be done in 5 minutes. It's okay, take your time. I want this data to be consumed slowly, and because this data is now being consumed slowly, what that eventually leads to is my EC2 instance, which is the rightmost part, right? That rightmost part now goes, this peak will never come. This peak will never come because एक साथ कभी 500 events आएंगे ही नहीं, क्योंकि lambdas पे ही हम लोगों ने वो restriction लगा दिया कि only 5 lambdas can consume it and only 5 API calls will happen at a single time, right? We have increased the amount of time required. It's going to run for 10 hours instead of 5 minutes, but we have reduced the load on our EC2 instances. So we'll just compare this architecture. This architecture has AWS SQS in between. The middle part is lambdas. Then you have the application load balancer. Those are the EC2 instances. If you look over here, you have the data source, you have the lambda, you have the application load balancer, and then the EC2 instances, only the SQS is missing in between. Just by adding this SQS, we were able to scale from 20 GBs of data to 120 GBs of data. How much do you think it went into adding that SQS queue? How much time would have gone into adding that one single component? Literally 3 hours, 2 hours, we did the entire thing. Right? We just put a queue, let it consume, change the API calls, and it just worked in 2 hours. Right? And I am still scaling by adding that SQS queue. We have still not gone to EKS, we have still not done microservices, we are still on that same infrastructure by adding a few things. So now when we eventually did this, getting a little bit ahead, this architecture worked for us throughout the entire life of the company. We never went back and changed this architecture. It just scaled. It scaled to 200 GBs of satellite imagery, it scaled to 300 GBs of satellite imagery, it scaled to 500 GBs of satellite imagery. We never saw this architecture fail, right? So now, when we eventually came to this architecture and we were like, this is now rock solid, this is now changing, have people used infrastructure as a code? CloudFormation, Terraform, Ansible, has anybody used? Okay, very, very few folks. Okay. So what basically this means is, when you open up an AWS console, you click UI buttons, and then once you've clicked those UI buttons, those changes happen. But on a Saturday, I'm here giving a talk, and if my friend or my colleague or somebody needs to know how I did something, they have no idea about how it's done. Because कौन सा बटन दबाया, कौन सी कॉन्फ़िगरेशन की, किधर जाके किया, डैशबोर्ड इतना बड़ा है, 50 सर्विसेज हैं, कैसे पता चलेगा क्या किया? So there is something called as infrastructure as a code, which is what is being followed to write your entire infrastructure as a code in a declarative manner in Terraform or in CloudFormation. So what we have right now is in infrastructure as a code, we had the AWS SQS queue, we had the event configuration to trigger Lambda, we had the Lambda scaling and concurrency, we had the roles that allowed the entire infrastructure to communicate with each other. This in infrastructure as a code is a lot of code. Like I don't have the snippet right now, but it was like at least like 200 lines of code, 250 lines of code, right? And then I think this is something that a lot of times engineers or people in general don't really talk about. When you have 200, 300 lines of code, you'll probably hear the team is scaling, we need to hire more people, we need to have more heads, we need to now have a DevOps team to do something else completely, right? When you have a load that is of like, let's say for example, 1000 RPS and you're doing infrastructure as a code, you'll say now my company is earning more money, I can hire a more expensive engineer, that engineer will now sit down and then that engineer will hire more junior developers who will then eventually go and maintain my code, and then you have maintenance costs because now you have hired. So scaling simply just does not mean that you need to scale your code and your infrastructure. As a manager, as a principal engineer, you will eventually reach into these scenarios where scaling also means that when your code or when your company has gone to 1000 RPS, 10,000 RPS, a million RPS, the same team is able to handle that load, right? Now, at this point, when we wrote this as infrastructure as a code, we had about 200 lines of code, right? And we were like, this is getting out of hand. We are not able to maintain this. We are not able to manage this. What should we do about this? So there is something called as AWS batch job, which is probably a bit on our part that we did not research this beforehand, but AWS batch job is exactly what this is. Like literally AWS gives you a managed service that gives you a queue with a consumer on the end that can run as long as you want. It deploys a EC2 instance on which you can deploy your container, which runs for as long as you want. As soon as the queue is empty, the container shuts down and your cost is gone. Turns out a lot of people had this problem. AWS realized that everybody is having this problem, so they released their own managed service. So that 200 lines of code, when we moved it to AWS batch job, is this much. This is the infrastructure as a code of AWS batch job. You write this code and you do CloudFormation deploy, and your entire infrastructure, this infrastructure will be deployed. That's, I think, like 10 lines of code. This is what the eventual output looked like. This is what was handling about 1 terabyte of geospatial data for the government of USA, right? So at this point, you need to realize that while we scale to a lot of RPS, we scale to a lot of GBs of data, we also kept in mind that maintaining code is just as big of a pain as writing and deploying and scaling is. Now the next developer who comes, or the next DevOps person who comes, has to just look at these 5 lines of code. And I am still scaling. Right? So this is, this is thoda sa complicated. So I am still scaling. This is me. This is me to my manager every time he comes to me with a problem of saying this is not scaling. I am still scaling, right? I think that's about it. That's the end of the talk. Yeah. That's about it, guys. Thank you so much. Do we have a Q&A? Any questions? Anybody? Cool. Yeah.
Wow, what a है question? किसको? So sorry.
No worries. I think there was a little bit of mismatch in terms of, I think a lot of people are yet to get onto cloud and the cloud services and all of that. Yes.
So you are still on monolithic architecture, right?
This part of the service, yeah, we are still.
So when is the right time to switch to microservice? So when are you planning to do so?
Um, that's actually a very good question, right? And the answer to that is not something that a chat GPT or I can give you, right? There are patterns, there are indicators, there are the stage at which your company is, your engineering culture, a lot of those things determine when to move to microservices. I'll give you an example. Um, is your team okay with doing distributed tracing? That's a question that you should ask before deciding should I move to microservices. You have microservice 1, you have microservice 2, you have microservice 3. An API call happens, it goes from microservice 1 to 3, 3 sends it to a queue, from that queue it goes to microservice 2, and then from microservice 2 it goes to microservice 5. Now something broke in between. You need to debug as a developer at 2:30 in the afternoon during your lunchtime कि क्या फटा. Your CEO is like, if this does not get solved by end of day, we are not getting the contract tomorrow. How are you even going to figure out ki, did it go to microservice 1, did it go to microservice 3, is it the queue, is it the microservice 2, did we never get the call in the first place? So is your team, is your engineering team okay with implementing a Tempo or Grafana to figure out what the distributed tracing would look like? If that is something that you can handle, you should go for it. So there are multiple questions like this that you can eventually ask to decide what is it that you want to go with, your monolith architecture, your microservice architecture, or some other type of architecture. Sorry? Yeah.
So why there is so much hype about the microservice architecture? Like why are not people still continuing using monolithic, and why they are shifting to microservices if it's so expensive and costly? Okay.
Right, this is why I put it in the first place. This is where we also started our talk from, where we said, I think it has sort of become a fashion now, right? A lot of YouTube videos, a lot of system design interviews, a lot of people selling courses on microservices, trying to make money of students, of people. Understanding, so this is not to take a dump on microservices and say you should never go to microservices, but there is a time to go to microservices, and you being able to figure out that time is now far much more valuable than you being able to implement microservices. Because now you being able to implement microservices, ChatGPT also can tell somebody. But knowing whether microservice karna hai ki nahi karna hai is far much more valuable, right? That is what you as a developer, an architect, or as a DevOps individual could provide your company with value. Second, why do a lot of companies directly go for microservices? Because I think somewhere in the past 6-7 years, that entire term became extremely popular, and everybody was like, if I don't do microservices, I won't scale, right? There are a lot of companies who are still doing monolith. They just don't talk about it. But there are a lot of companies who are doing monolith and they're doing very well.
All right. Thank you.
Yeah.
And Content Stack is the founding member of an alliance called MARC Alliance, if you've heard of it. MARC stands for Microservices, API First, Cloud Native, and Headless. Okay, and Content Stack competes on one end of the spectrum with the likes of Adobe Experience Manager, which is essentially a monolith. And in a lot of our marketing messaging, we are increasingly talking about composability is the way to go. Of course, like we have been discussing that there are instances where monolith is, of course, better. Why why fix something if it is not broken? But then there are situations, there especially enterprise situations where we are looking to scale. Then is when we should speak about composability. And I would encourage you to go to the Content Stack website. There is a lot we have been discussing, talking about. So this will give a perspective. Of course, it is a classical answer where whether to go monolith or microservices composability is the answer of it depends. It is dependent on what use case you are trying to solve. So that's my perspective. I'm a non-techie, by the way, so pardon me if I have not added any value to this conversation.
No, that's exactly on point, right? And the entire point of having this sort of an architecture also is this service is not a microservice, right? This is a monolith, but we have other services that are potentially microservices. We have other services that are microservices, right? But the talk also is not monolith versus microservices. It's about knowing how to scale, when to scale, what to introduce, when to introduce, and all of those things also.
So by the way, Content Stack as an enterprise B2B SaaS platform serves 2 billion API calls per day. Okay, so that's the kind of scalability we are talking about. All right.
So I want to add something on the monolith versus microservices. Like it's a question like when we can go for it. So whenever we are building application, first of all we need to analyze the logical unit. Like if we take the example of Flipkart, customer registration is one part, sales is another part, adding a product is another part. So before that we need to understand how much traffic we are going to get and what is the logical unit. If you have this answer, then you can go with the microservice. It is similar like suppose if we are going on a road and we have a single road, the traffic will be there. So what the traffic people are doing, they are diversing us. So it's just an example of microservice. And suppose, and also one part, like if your application is legacy system, like we have built very long time ago, it is not easy to convert the monolith into a microservices because monolith application is already tested. So same thing activity you need to do there. So it's a very huge effort. So how we can solve the problem quickly? So we have a concept of horizontal scaling as well as vertical scaling. So based on your requirement, this will get done. Like without converting a monolith application to a microservices, you can opt for the scaling part, like which he is talking about. So horizontal scaling, vertical scaling, these are in the market. And also like scaling is now easy. Like few decades ago, it was a manual. Like we were having a rack server, where we were calling the IT people, they were shutting down the server, they were increasing the RAM, changing the CPU. It was a time-consuming process and there was a downtime. Now you can scale the app in just few seconds. Just you need to select your computation power and you have to pay for it. And suppose if that scaling is completed, automatically it will went down. But in case of earlier approach, where we have a physical server, that server people already buy that server hardware for you. Now you can't do the downscaling. So nowadays scaling is just on one fingertip. So there are many things which we need to find the answer before we convert the monolith into a microservices.
Hello. Sir, my question is, can you explain the geospatial data pipeline from the web scraping to collecting the data to converting from till the insights? Like you mentioned, government tie-up something, and you are gathering the data from there. It's a real time. So another one question is, explain about the AWS SQS that scale up the 20 GB data to 120 something you mentioned. So how it can be possible, or can you explain that?
Yeah, sure. So starting with what geospatial data is, right? There are a lot of government launches satellites, right? And these satellites provide certain amount of data. Government has certain policies around what is private and what is public. So these satellites provide publicly accessible data. If you want to render the entire map of India on a very high density, there's something called as OpenStreetMaps. If somebody might be following the Ola versus OpenStreetMaps thing that is happening very recently, OpenStreetMaps is a very popular geospatial, they're not a geospatial provider, but basically they work in the geospatial area, right? This data is publicly available. You can call their APIs and you can get this data. Once you get this data is not in the format that you need. You need to reformat this. You need to scale the images. You need to do reprojection. You need to do remapping. You need to do segmentation. You need to run different data science models on it. Those are the transformations that happen. It's very similar to how you would do ETL data or extract data from your database, manipulate it, send it on the front end. Instead of sending it on the front end, now you're storing it in your database. So you take data that is publicly available, you transform it depending upon what your ML model looks like, and then eventually the output is stored into database. We used a Postgres database with PostGIS extension that manages your geospatial data. So eventually in our database, we stored the shape of a lake, which was a GeoJSON, which is what the last speaker also spoke about. It's the shape with multiple different polygons, right? That is what we eventually stored in our database. Talking about how the entire data pipeline looked like, there was something like this. So we would have multiple data sources. Each batch job was individual batch job. First batch job would do data cleaning. If the data does not has a lake in it, if the image, satellite image does not has a lake in it, just remove that satellite image. We don't want to process it further. But if it has, send it to the second pipeline. If the second pipeline evaluates something, it becomes true, send it to the third pipeline. Third pipeline evaluates something, send it to the fourth pipeline, right? And there are multiple n number of pipelines, one after the other, which eventually dump your data into the database. That's how the entire data pipeline looked like. Coming back to how did the SQS solve it for us? So SQS is a queuing service. It's very simple. It basically, if you send something to the queue, it'll be there in the queue. It's like autoca line, right? If a person is standing in the autoca line, until unless an auto comes and picks you up from that line, you're still going to stand over there, right? Now SQS, AWS says that SQS will scale to millions of events. It's a distributed scaled queue. If you don't like SQS, you could use Kafka, you could use RabbitMQ. There are different types of service providers for queues, right? But in this case, we used SQS. In that SQS, the data from the publicly available data would live. Now, if you wanted to process it, we would process it. If there are like, on a day, if we had 50 GB of data, in that SQS, that 50 GB of data would be present till the next 3 days, 4 days, 5 days. So it didn't matter even if we had to scrape 120 GB of data, 200 GB of data, 500 GB of data. Eventually we scraped on a daily basis, we were scraping around a few 800, 500, 900 GBs of data eventually, which was just living in our SQS. Any other questions?
I think we are done with the Q&A session. So thank you so much, Yash, for that not only insightful and learning session, but it was very entertaining. It is not every day that you get to learn and laugh on such complex topics and make it easy so that a crowd like external audience can also engage with the topic. Thank you so much. So let's give a big round of applause for Yash.
Thank you to TechX, all of the organizers, Content Stack for hosting us and inviting me. It was really fun being here. Thank you so much.